I know the chat screen gets logged, so we can go in and repost the chat. So I'm going to try to, just because the video feed probably is going to be pretty bad, I'm going to try to type as much as I can. I'll talk too, but I'll try to type some of these answers as best I can. Is it -2 and -2? How does the t-set of 2 differ from 3? So for Jeff's question about negative t-sets, I think I have a video about that. Let me see if I can find it, and then I'll type in the chat where you can locate it. And this is probably going to take forever to load up this page. So at this point, I will say, I'm pretty sure I have a supplemental stats. Standard here. The connection is unstable. Let's see. Yeah, there we go. Video 10. This talks about negative t. Talked last night about where these t-stats come from. So if people were here, the t-stat is just the coefficient divided by the standard error. The standard error is always a positive number. And so if your coefficient is negative, like if you did the effect of price on quantity demanded, then you expect there would be a negative relationship there. Then that coefficient is always going to be negative. And the standard error that comes out of that regression is always going to be positive because it tells you how far the data is spread out. So when you're calculating your t-stat, which is the coefficient divided by the standard error, you may have a negative coefficient divided by this positive standard error, so you get a negative t-statistic. That doesn't really matter. What you're looking for is, I guess you could say, the absolute value of the t-stat. You would like that to be larger. So if you had a t-stat of 3 or -3, it most likely is going to be significant. If you had a t-stat of 0.7 or -0.7, both of those would probably be insignificant. So you're just kind of looking for the absolute values of those things. How does a t-stat of 2 differ from a t-stat of 3? Since, again, I'm going to type these, since the t-stat is coefficient divided by standard error, a t-stat of 2 suggests that the spread of data is larger, less accurately predicted. So again, the standard error tells you how far apart the data is spread around its predicted value, its coefficient there. So if you have a larger standard error, that's going to make the denominator of the t-stat fraction, which is the coefficient divided by the standard error. If your standard error is big, meaning the data is spread out, then that t-stat fraction is going to have this larger denominator, which is going to make the t-stat itself be a smaller number. So a t-stat of 2 compared to a t-stat of 3, you can interpret that as, well, the spread of data for 2 is more spread out, but the data for a t-stat of 3 would be more tightly packed around the predicted line. So you would have more confidence in making a prediction if the data is more tightly packed around that estimated value than if the data was more spread out. Which is why a t-stat of 3 is more significant than a t-stat of just 2. There's no dependency between sets of data. Should we deal with each set separately? I don't know if I'm understanding George's question about dependency between sets of data. So if you want to either do a follow-up over the microphone, or if you want to type it in. If you type it in, it might be more likely that I would be able to hear it. Because again, my connection seems to be pretty awful tonight. If a value is not statistically significant, should it be dropped from the model? If a coefficient is statistically insignificant, significant, then I tend to include it if you think it is still theoretically important. Theoretically. Don't just drop variables. Let's look bad. Okay, let me see if I can. So I got George's question. So I got to back up quite a bit. For question 4 on the assignment, should we use Model E to answer the final question? That'll be up to you. The question about, for question 4 on the assignment, should we use Model E to answer the final question? That's something for you guys to ponder and think to yourselves. Okay, so then there's my own comment. Another one of my own comments. How does marginal revenue from the last unit sold differ from the marginal revenue calculation? Well, marginal revenue just means the extra revenue that comes in. I guess I should say this. Marginal revenue is just the extra revenue that comes in from the last sale. So, I mean, the question in the, again, I assume all these questions are related to the assignment. Where was that at? Oh, here we go. So in 2B, I guess I'm not sharing my screen. In 2B, you had the question about what is the marginal revenue from the last unit sold. It's just asking what is the extra, how much extra revenue is coming in from the sale of that last unit. So it's not, it's not asking about an equation or anything like that. It's just, it's just saying if you do this sale. So for the first part of B, you're saying what is the optimal level of output for your company to produce or sell. So you're deciding on this amount of output to produce, and we'll just say it's 100. So you decide to sell 100 units. The question would be, what is the marginal revenue from selling that 100th unit? Once you've sold the 100th unit, what would be the marginal revenue that comes in for that? So that's what that question's asking, if that makes sense. Let's see. Okay, some of my other comments. I heard in the news from an election call for Arizona say we have a T-stat of 4, and they are 100% in the call of who would win the state. So they're talking about T-stats. We had a moratorium last night of not talking about any election stuff because we didn't want to make anyone mad. We didn't want to get distracted. You guys pay tuition to learn about economics, not about what's happening in the world of politics. So, but it's kind of funny if people are talking about T-statistics at these polling places. All right. Yeah, I mean, for George's question about the data sets not being related. I mean, it's true. You'd have kind of separate phenomena going on between the employees and their production and the robots and their production. Let me get that was a part 1 section, so. Oh, there we go. There is a section in this set of slides that talk about, most of what we do near the beginning is trying to decide the level of an activity based on its costs and benefits. So we said, you have how much of this single activity do I want to do? 200 units of this activity, 500 units of this activity. So I'm basically making one choice along one axis. Along one dimension. I got to figure out how much of this one thing do I want to do. That's not quite what this question number 1 in your assignment is asking. Question number 1 in your assignment is asking how much of 2 things do you want to do? How many employees do you want, and how many robots do you want? So there is a section. There is a section in this set of slides in this lecture video that talks about how you are able to how you're able to think about decision making where you have 2 things that you want to pick from. So I'm going to stop my share just to make sure. I'm going to look at that section. Yeah, there we go. So it is there. Again, I'm not going to point it out to you exactly, but it is in this week's discussion. I will cryptically say in the chat, this week's part 1 was about optimizing the level of a single activity, but not just that. Ended it to more than one choice. All right, so hopefully that helps a little bit. You'll notice that if you ask questions about the practice problems or anything in the actual lectures, that I will go into great detail in trying to answer those things. If you ask me questions about the assignments, I'll be very cagey about it. So I'll try to give you some hints. And I usually try to give a little more hints to people who take the trouble to come to the Zoom sessions than I would otherwise. But when you have to record the whole Zoom session, it doesn't make much sense. Okay, so employees don't seem to be late. Explain question 1 of the assignments. We've explained a little bit of question 1. If there's anything else that a lot of people seem to be in the chat at least asking about question 1. So if anyone had any other things we needed to go over, aside from the lecture itself, I will remind people that there are the practice problems where you might get a little bit of extra insight by looking at the second practice problem, of which there is a video in the supplemental section about that too. So here's module 2, practice problem engineers question. So there's a video number 8 about that. But it is about hiring between these 2 types of people. You have engineers and researchers. You might think, oh, they're both people, so it's like, how many people do you want to hire? Well, it's 2 different types of people. You've got the engineers and you have the researchers. So if you're looking for some direction on question 1, you might go over practice problem number 2. All right. Anyone appreciate the name of the company in question number 3 in the assignment this week? I try to put in little Easter eggs like that in the assignments. Maybe like 1 per assignment. So yeah, and then the question 4 about crime. Speaking of 3-part F, can you guide me to direction? Well, 3F is, let's see, it's going to be, since it's question 3, for those of you who have not been here before, I usually mention to people that all of these assignments are going to have 4 questions, and always the first 2 are going to be related to that week's part 1 discussion, and all of the assignments 3 and 4 questions are going to be related to the part 2s of that week. And so, since this is a question 3, it means it's related to regression, and obviously you've got regression results there. So the nice thing about, the whole reason we run regressions is not just to look at t-stats and p-values and r-squareds and say, oh, that's a good thing. It's like, if you bring your car to get fixed, you might feel kind of nice knowing that, well, this mechanics place, they did a quality job looking at your car. They did all these tests. They use this kind of quality oil. And you might be like, oh, okay, that's good. I'm glad they did a good, they used all the highest quality equipment at this mechanics place. You want to know if you can actually drive out there and your car actually work. So you want their work to be good. You want their work to be of high quality, but you actually want to drive your car when it's done. So I can look at these regression results and I can say, oh yeah, this is a good set of results. The R-squared is good. P-values are such and such. Coefficients are what I expected. I'm not saying that they are in this question, but in my, as I look at regression results, I might say that to myself. But it's like, you want to use these regression results to do something. You want to actually use them for something. So as we talked a little bit about yesterday with question 6, I'm just hoping everyone can still hear me with my bad connection. If not, say something in the chat if you can even hear that. But I could look at this, and actually we don't have it because I don't have all I have is the R-squared. I don't have the p-value. So let's go. I'll just show you what I've been talking about a little bit with these PowerPoint slides, how you can get into the actual underlying data that's here. So let me go in and edit data in Excel because I want to be able to use the regression tool. See, I'm still showing my screen, right? So I've got sales here and the amount of advertising. And again, just to verify, if I wanted to make a chart here just in Excel, you can see it, and it ends up being the same picture. And as I mentioned last night, one of the nice things about having these charts is you can plop a trend line in there, and you can not only look at the trend line, you can not only look at the line that best fits the data, but you can also, in the trend line options, is it going to do it here? Probably not, because it's within. Oh, there we go. So even though I'm in PowerPoint, I still have some of the Excel functionality. So I'm plotting this trend line in here, and I'm making it be linear. And so I'm going to get a regression equation that has this intercept, 1387 as an intercept, and this 5.386 as a coefficient. So I can tell Excel to show me that equation. I want to see that equation, and I want to see the R squared there. So that's kind of nice. The only bad thing is that I don't have the t-stats. So I don't know whether this, the coefficient for A, this 5.4, is, if I have confidence in that, if that's a significant estimate. So I need to go back in here into Excel. And again, I'll do a regression, which is, where's my, oh, I wonder if this is going to mess me up because I need my data analysis tool pack, which is an add-in analysis tool pack. Let's do it this way. It should be there. Just because I'm not on a big enough screen. No. Okay, this is bugging me. Let me open Excel on its own instead of this weird PowerPoint version of it. The sample questions are in the they're in the to-do list, the optional section of the to-do list. You can find the practice problems if that's what you were asking about. Where do I post the Zoom meetings? I'm going to put the Zoom meetings at the bottom of the supplemental playlist in multimedia once I'm done with that. I'm just trying to catch up here. Does R squared or does R squared better explain variation of things of the same regression? My usual rule, we talked about it last night, if your regression equation has more than one independent variable, I prefer the use of the adjusted R squared, because the adjusted R squared will do for the inclusion of independent variables that don't really add much of anything to the explanatory power of the model. They can actually make the R squared, the adjusted R squared can actually get pulled down if you add an independent variable that's not helpful. Whereas the R squared won't do that. The R squared doesn't really penalize you for including a variable that's not very helpful. So anyway, let me show the regression here. Advertising revenue. I've got the labels there. So put my output, just put it right there. Now let's put it up here. So this stuff is not really interesting to me, nor is this stuff, and even a lot of the other results up here aren't all that helpful. But I can see that I'm getting the same results here. So this line was y equals 1387 as the intercept, and then the advertising coefficient was the 5.386, and so that's what this is here. And again, I can look at these things. I can say, oh, look at that R squared of 0.784. So there it is. There's the R squared that it's showing me. But the nice thing about running the actual regression is that I can get a look at the t-stats and the p-values. And I can say the advertising revenue is significant at 1%. So there's a greater than 99% chance that the amount of advertising does affect sales. Or to put it the other way, there's a less than 1% chance that advertising does not affect sales. So advertising does seem to be important. I want to use these results though. And so I can look at this equation and I can, well, it's written out over here. They showed you the equation already. So sales equals that 1387 plus 5.4 times your advertising expenditures. And I want to be able to use that equation because someone might say, you can see all the sales numbers here. And if someone said, you can see all the advertising numbers over here. How many sales would we have if our ad was, it's pretty easy if someone said, hey, if we spent $400, how many sales could we expect? You could say, well, we have some experience of having $400 of advertising expenditures, and we had sales of $2,900. If I look at the data points, I might say, yeah, that was kind of, that was okay. That did kind of lie somewhat far away from what my guess of what sales would be. But what about what's going to happen to sales for an amount of advertising expenditures that's not in this table? I can see that there's no $300 of sales here. If our ad was $300. So there's nothing in here. I might be able to eyeball it a little bit and say, well, I've got 200 was 2,400, and when I had 400, this was 2,900. So if I went like 300, maybe it would be some point in the middle of those. But in the world, what if it was something weird, like 368 or something like that? It doesn't really matter what kind of strange number you might think about. You can use the equation to make predictions for anything, and I'll just go back to using 300 again, just to make it simple. So I want to use these regression results, and I could say sales, and it's 300. And I could kind of be a little messy and say 1387 plus 5.4 times 300, and I'll get some value, 3007. What I always prefer doing, though, is Excel has already told me what these values are. I already know this isn't really 1387. I mean, it's 1387.332, blah, blah, blah. There's more decimal points after that. So I'm just going to use the results that it's giving me. So I'm going to say equals, point to the coefficient cell so that Excel knows in this equation that it's going to refer to that value. Plus, now I don't want to just type 5.4 because that's rounding this quite a bit. So I'm just going to point to it. And so Excel knows it's not going to do 5.4 times 300. It's going to do this whole big nasty number. So that, and then I'll say multiplied by the $300 of ad revenue that we have. And I get this big number. It's different from the 3007 that I got when I rounded these things. But I would argue this is as accurate as Excel can give me because it's referring directly to the cells in which it calculated these coefficients. So I'm trying to remember which one of your chat questions prompted me to do all this. Oh, it was the speaking of 3 part F. Because 3 part F is basically asking you that. I mean, because I say here, how many sales would we have if our ad was $300? Because I was able to look at this equation from slide number 6, and I can plug in, whatever value you might think of for an advertising expenditures, and it'll predict the amount of sales I'm going to get. It's going to be predicting it somewhere directly on this line. So if you see the 300 value for A, it does, I mean, it looks like it's sitting right on top of the 3,000 sales, but I can see here that it's actually 3,003, which is going to be pretty imperceptible on this line, but so slightly above where that 3,000 horizontal guide is. But it's kind of a similar question as to what I have in part 3F. What level of monthly sales, which was the independent variable, or sorry, the dependent variable here. What level of monthly sales would we expect in this new city? And the only bit of a difference here is that I had an intercept and 1 independent variable. In this question, you've got an intercept and 2 independent variables. In the question that I had, it was, I gave you some hypothetical value for advertising, and you were able to plug that in and figure out how many sales you would have. So you probably would do something somewhat similar in question 3, part F. So hopefully that helps with that. Again, you could go in and say, like I said, 3, or whatever I said before, 386. If sales are $386, I can just go in, my little equation is still set up here, make that change. So if we advertise $386, we would expect sales to be around $34.66. So again, if I just kind of eyeball this a little bit, 386 would be maybe somewhere over here. And my prediction is $34.66. So that's probably right around where this line is. $34.66 if we spent $386 on advertising. You can get a sense now of, hopefully as I'm doing this, of why we focus on this idea of p-values and t-statistics about these variables being significant or not. Because I'm using this equation to make predictions about how many sales I'm going to have. And so every prediction that I have for sales, though, every time I use this equation to make a prediction for sales is going to be some point on this dotted line, exactly on this dotted line. So when I thought it was 300, then the prediction was 3,003. When I thought it was $386 for A, my prediction was 34, whatever it was, 34.66. So every value of A that I'm going to consider, if I plug it into this equation, it's going to predict a sales amount that's exactly on this dotted line. And so if my dots are far away from that, if I've got these dots, and these might look like they're far away, but actually the R-squared is pretty good. And the p-values are pretty good too. If the dots are really far away though, and your predictions are going to be right on that line every single time, then even though in the real world, the data points are spread far away from this line, every prediction you make is going to be on that line. And so if the data is really spread out, then your predictions are probably not going to do a very good job. You're going to just make a prediction and say, well, I think this is what the value is going to be. But it could be pretty far off from what the values have actually been in the past, in the real world, and what they might actually be in the future when you make your prediction. If the data points are really close to the line, and you're making predictions that are exactly on the line itself, then again, you can have a lot of confidence that, well, I'm going to make a prediction which is right on this line, and all the underlying dots were really close to it. So I can have a lot of confidence. I can have a lot of faith that the prediction that I make for sales is going to be pretty close to what the real world value of sales would be at that level of A. So let's see. So yes, I'm going to try to post the Zoom meeting to the supplemental playlist in YouTube. I will make sure I stay up late enough to upload that thing. The reason I didn't do it last night is I was working on some consulting stuff until like 3 in the morning. And I didn't think about uploading the video until then. And then I looked at it, uploading, the little progress bar was barely inching along. I'm like, I'm not going to stay up until 4:30 until this thing finishes uploading. So I ended up losing last night's recording, but I'll try not to lose tonight's recording. Where do you find this? So yeah, simple questions are in the optional section of the to-do list. Also, that's where the PowerPoint slides are. People have been sometimes asking, where can I find these PowerPoint slides? And they're in the optional section of the to-do list. On question 1 on the assignment, do we assume that the budget constraint is the mix of employees, robots, cost data, and problem 1B? You don't really need to think about the how much budget the company really has for part 1. I mean, you could presume, I suppose, that every combination that's here is affordable to the company. So you could tell yourself that even if they used 7 employees and 7 robots, that would still be affordable for this company to do. So, but you should be still able to answer the question without having to know what the company's budget is. It's enough to know the marginal products that are there and the prices of each of those inputs. Okay, what was the name of the Excel add-on? Yeah, if you have Excel, I don't know if I have a little discussion in this. I think I might have it at the beginning of there's a PDF about using Excel to run regressions in the readings page of this module 2. I think I mentioned it in there a little bit. So yeah, there's this using Excel to run regressions. I'll show you in a second, but I'm just wanting to make sure it's still there in case people forget. Yeah, there we go. It's the analysis tool pack, and it's one of the add-ins. So as you saw, well, my version of Excel does have it, but sometimes you'll open up Excel and it won't be there. You'll have the data, you'll always have the data tab there. And what you're looking for is this data analysis little button. And I have it now, but sometimes I don't. I've had versions of Excel in the past where you add it, you put it in there so it shows up, and then the next time if you close Excel and then reopen it again, it's gone, and so you have to kind of go through and do it every single time. So if you open your data tab and you don't have it, then you need to go back to the file menu. You need to get into options somehow, depending on what version you have. And once you're in the options, you look for the add-ins. And I never like doing things from this page, like clicking on things through here. I always seem to have a lot more luck down here when it says manage those Excel add-ins. I hit the little go button. And then if this is not selected, if the analysis tool is not selected, you can go in and select it, hit OK. And when you go back to the data button, it should be there. You should see the data analysis tools little button. You pick it, hit the button, and it usually starts at, what does it usually start at? It usually starts at histogram, descriptive statistics. You end up needing to scroll down to get to regression, and then you can run your regression from there. But I tried walking you through that a little bit in that using Excel PDF, using Excel to run regressions PDF. Okay. 8.2095 to the negative 10, that is a quite small number. Anytime you, I tried mentioning, I think, yeah, so it's right here in question 4 that you might get some, and these usually show up for p-values. The t-stats, I mean, you might get some coefficients that are really small or standard errors that are really small. They usually show up in the p-values of where you get something like this 2.4 to the negative 0.6. And this is just, as I say, scientific notation for 2.4 times 10 to the negative 6th, or this really small number like this. So if you got an e and then a negative sign and then a number, it usually means the number is pretty small. So yes, this negative e to the negative 10 is very small, close to 0. The only one doesn't have the mutt to custard. No one's heard the phrase cut the mustard. This thing doesn't cut the mustard. I gotta go. You never know what's gonna show up when you do these kind of things though. Where does the phrase cut the mustard come from? I don't know where it comes from. I hope it tells you what it means. Oh, there we go. Cut the mustard is to reach or surpass the desired standard or performance. For instance, Beyonce really cut the mustard in her new song. I'm sure most of you have said that at some point in your life. And the quarterback couldn't cut the mustard in the playoffs. So, can a robot run less than 1 full hour? And don't get caught up in the things about hourly things happening here. If it helps you at all, just say everything in this table is an hour. Things are happening all in an hour. So you don't have to sit there and like, well, what if this thing only goes for half an hour? What if it goes for 2 hours or 3.7 hours? The hours part of it is you don't really need to focus on that. Again, everything you'll need to be able to do this analysis is pretty much here in the table, and then the fact of the prices of those 2 inputs. In 2C, are net benefit and net revenue synonymous? Yeah, I mean, they're also synonymous with profit. I mean, I know in some fields, some disciplines, finance, they might talk about net revenue instead of talking about profit. They might not just actually use the word profit. Some places might. I've come across, well, especially in finance, they'll talk about net present value. So the net term means that you're subtracting something away from it. And, economists, you usually just say profit to mean total revenue minus total cost. Again, some other disciplines might use some other terms. So I wanted to, all 3 of those things are kind of synonymous with each other. Net benefit means that you think about the benefit you're getting, but you subtract off any costs that you have. Net revenue would be the gross revenue that you get minus any costs that you have. And to me, all of those things just kind of are the same thing as profit. So I put them in parentheses there just to say these are all synonymous terms that you may have heard before. Not anything to do with any part of it, but what point do we accept a seemingly unrelated variable that is statistically significant? And sometimes that might happen, especially with some of the I included some variables in the robbery stuff that might seem like, well, I don't know why that's. I remember when I was at a conference one time, and someone was presenting a research paper on some crime thing. There is a field in economics, the economics of crime, that is kind of interesting to look at. And so they were talking about their paper, and they included some stuff that you would probably think would be obvious. So if I'm trying to figure out how much robbery is going on, I would probably use things like, what's the murder rate, what's the population, how many people are in a metro area, what's the level of education, or the age of people. in that area. But they also included things like the amount of rain or the amount of sunshine in this research presentation. I was like, what? Like a criminal sitting there deciding whether they want to, they're casing this bank, and they're getting ready to go out. They open the door, they feel some raindrops, and like, yeah, now we'll do this another day. But they showed that it was significant, at least in this research project. So I threw it in there just to see, as something that I think you guys could look at and see if you see anything about it. So it might look like it's seemingly unrelated, but there's debates about, in the field of economics, not just economics, but a lot of social sciences now, about the whole issue of using these data sets and running regressions, and what do they mean? Like, how significant are they? How important are they to the overall society to come up with these research projects, and what do they tell us? Because you got people that will run regressions. It's so easy to run a regression now. You just do it on Excel. You can run regressions really fast. And there's, as I was talking about last night, there's the temptation to just throw in every independent variable that you think might be important, and you look for your R. You're trying to get the biggest R squared you can, because you want to have an equation that when you're done with it, you can say, yeah, I think this equation does a good job. I think my equation does a good job of explaining how many sales our company is going to have. If you walk into a meeting and you're trying to talk to the board of directors, and you're saying, hey, I have a new idea for how we can project the amount of sales that we're going to have, and I've had this equation that I've analyzed some data, and I've run a regression. I've got this equation that will help us to predict the amount of sales we're going to have based on the amount of advertising revenue that we have. And your board of directors says, oh, good. How accurate do you think these predictions are going to be? And if you had an R squared of, like in my dissertation, if you had an R squared of, or an adjusted R squared, whatever, of like 0.07, that was the R squared that I had in my dissertation, the thing that showed up a lot. I ran several regressions, but that one seemed to show up quite a bit. So I had tons of data on house sales in Dade County and lots of these independent variables. And I was able to explain 7% of house sales. And so if you came to your board of directors and said, I got this great equation, oh, how accurate is it? Well, I can explain about 7% of the variation in sales that we've had. So they would say, so you mean you can't explain 93% of the variation in our sales? Yeah. So since that's there, there's this temptation to just throw in every independent variable you can think of. And if it makes the R squared improve, if they're significant, then people just go, oh, keep it. We're going to keep it. There's I linked to the Econ Talk podcast sometime, and there's a story that he likes to tell about, it wasn't this kind of equation exactly, but I'll use this example. Maybe let's think about the sales that we have, not necessarily based on the advertising budget we have now, but maybe our sales today depends on our advertising budget from last month, or our sales today depend on our advertising budget from last month, and another variable for the advertising budget 2 months ago, and another variable advertising budget 3 months ago. And so the host of the Econ Talk podcast said he was at listening to another research presentation, and the person said, we think what's really important in explaining sales was the advertising budget 17 months ago, because that ended up showing up significant. And it was like, so none of the other months mattered. You just ran your regressions and you got that to be the most important result out of it based on just the p-values and t-stats and stuff. And so it's like, some people will, again, just throw in these independent variables hoping that they help improve things. And they might improve things just in the raw sense of that these numbers look better than other models that they might run. If you do have some seemingly unrelated variable that does show up to be significant, a lot of times, again, an economist will usually put in independent variables that they think is important. So you might not just randomly throw a variable in there if you don't think it's going to help. But maybe on a lark, you decide to put one in. So if you do have a seemingly unrelated variable in there that does show up to be significant, it's kind of one of those, oh, okay, that's kind of interesting. You might try doing another data set with similar variables and seeing, does this show up significant again? If you see it or not, it could just be a fluke. It could just be a statistical fluke, like the first letter variable in the using Excel to run regressions PDF. So it could just be a fluke. In which case, if you run another data set with similar variables, you might end up seeing that this unrelated variable really is unrelated. But again, it's one of those things where you go, oh, that's kind of interesting. So you could if you're trying to explain it to someone, you could say, well, I have this model and, it does decently well as far as the R squared. Most of the seemingly related variables show up with expected signs and their p-values are good. There was this one variable that we had in there and it's, had this kind of weird result. It showed up as significant and we weren't quite sure what that means. And that's when you can kind of do a cop-out and say, we're going to do some other analysis and see what's going on with this variable. But getting back to my main point, blah, 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 and you can continue talking. So again, it's kind of one of those things where if you have this unrelated variable that does show up as significant, you could try running other models. Sometimes what people will do, if you have a big enough data set, your initial regression might be over the entire data set. And again, you might get this weird result. You could also try like cutting your data set in half and just kind of randomly picking half of the data points and running a regression again with the same independent variables, but just over this random half of the data set. So it's a different data set, kind of, and you run the regression again and see what happens to the results for that variable. Maybe it shows up as still significant, maybe it doesn't. So that might tell you something else too. Or again, like I said, you might just be able to, you might have access to another data set that is completely different. You might have access to another company's sales and their advertising budget. And you can say, well, let me run a regression there and see if those results are consistent with what I have here. So there's a few other options you could do. At what p-value should you delete a variable from your regression equation? Well, again, that kind of goes back to what we were just saying. If my usual go-to response to a question like that is, should we include a variable or should we get rid of it? My usual rule of thumb, and I just got this from my econometrics teachers, my econometrics professors when I was going through college and grad school, was your main driver of what you include and what you exclude should be theory, should be economic theory. So if I'm running a regression on sales, what affects the sales, then I certainly do think that advertising expenditures is theoretically important. When people are deciding whether they want to buy our product or not, they're probably going to be influenced by how much advertising we do. So I want to include that theoretically. There may be other variables that I don't think are theoretically important, so I would exclude those. So I would exclude, how many squirrels live in the town that this store is located in, because I don't think that a company's sales will depend on how many squirrels live in this town. Maybe, who knows? But theoretically, I would say that doesn't really make a whole lot of sense. So I would exclude that. Again, you might get some people, some unscrupulous data miners who somehow they have access to the squirrel population and they throw it into their data set and they go, oh, that ended up being significant and the R squared went up when I included the squirrel variable. I'm going to put that in there. But then you end up having to tell your board of directors that they need to start funding a squirrel population, increasing the squirrel population program. So again, theory might tell you whether variables should be excluded, and it should tell you whether variables should be included. If you've included a variable that you think is important, it might show up as insignificant. It might even have a coefficient that ends up being the wrong sign that you think. And even worse, it might have the wrong sign and it might be significant. So it would be pretty weird if we ran a regression like this and found out that the coefficient variable was negative and significant, because that would imply that the more you advertise, the fewer sales there would be. What the honest person would do, what the honest econometrician would do, would be wherever they're presenting their results to include that. They would say, I ran this regression, I ran this model, I thought this was a good model to use. The theory says I should have included these variables, and the theory says I should have not included these other variables. So I ran this regression and I got these results, and I got this weird result on this variable that I thought was important, but it ended up showing up either being insignificant or it was the wrong sign. I'm going to be honest with you and transparent and say these are the results I got. I ran these other models too, and I got maybe some results there that were a little more along the lines of what I was thinking. But again, you don't really want to, it's kind of seen as a bit unethical in the field of statistics if you are just kind of, like I said, picking and choosing independent variables, throwing them in, looking at the results. Oh, that's not so good. Let me take this one out. Run a regression again. Oh, that one looked a little bit better, but there's other variable. Maybe I'll toss that one in there and that's going to make the results better. It's kind of, picking variables based on the results is, as I said, kind of considered to be a bit unethical or certainly unprofessional, I suppose. So, yeah. Hope that answers that question a little bit. Oh, so yeah, so at what p-value should you delete a variable from a regression equation? If you think it's theoretically important, you just don't delete it. You just say, it showed up as insignificant. I thought it should be significant, but it showed up as insignificant. So you could say that and say, well, so I got a result like that. I will also show you the results of a regression where I take that variable out. And as I mentioned, usually the cutoff is a p-value of 10%, or if your p-value is 10% or lower, then we say it's significant. So if you get a p-value that is 0.12 or 12%, then you could say, well, that doesn't quite meet the line, the cutoff that I'm looking for. So I would call that insignificant. And again, if it were me, I would still report that result and say, this advertising thing was insignificant. Its p-value was 12%. I think it's theoretically important, so I wanted to include it in there, and I'll show you these results. I'll also show you the results of a regression without that variable in there, just to be complete. But if it's theoretically important, I would want to include it. What's considered a large t-stat? Well, you're always going to get, if you kind of pay attention to the relationship between these t-stats and p-values, you can see when this t-stat is 4, I'm already getting a p-value that's less than 1%, which is pretty good. Again, there's only a less than 1% chance that advertising and sales are unrelated. So that means there's a pretty strong relationship between these two variables. There's a greater than 99% chance that advertising and sales are related in some way, and that you can have confidence in this 5.4 number. There's a less than 1% chance that they are not related. So that's only a t-stat of 4. You said a t-stat of 100 or a t-stat of 5.5. Those are going to make the p-values even smaller. If you had a t-stat of 5.5, this number is going to be even smaller than 0.008. It might even be the 8.2095 e to the negative 10. That might be why you're asking me about that. So if you get a t-stat that's 100, that's pretty. That doesn't mean that variable is important. That just means that you can have a lot of confidence that the relationship between advertising and sales is this 5.4 number. So again, I try to stress this sometimes, that when we say that a variable is statistically significant, it doesn't equate to the idea of significant as we usually use it in common English. And if you say something is significant in common everyday English, that generally means that it's important. This is an important, it's significant that you watch the news, or it's significant that you need to go out and vote. We generally mean those things are important things to do. When we say that a coefficient is statistically significant, that doesn't mean that advertising is an important determinant of sales. What it just means is that, as I said, Excel is trying to come up with a line to fit through this data, which means it's trying to come up with an intercept and a slope coefficient, this 5.4 value. And what I want to know is, how much confidence should I have in this estimated line's ability to predict sales if I give it a value of A? And as I said, if the data points are spread far apart, I shouldn't have a lot of confidence in it. And if the data points are packed tightly together, then I could have a lot of confidence in that. So that's really all the p-value is telling me. If the p-value is really small, the t-stat is large, then I can have a lot of confidence in this 5.4 estimate. There may be other variables that are a lot more important in predicting the amount of sales than what the advertising budget is. But if its p-value is really good like this, then I can say, okay, at least I know that if I'm going to use this equation, I can have a lot of confidence that this 5.4 number was estimated well, or was estimated precisely. So as you see, again, as you're kind of looking at these things, our cutoff is usually around 10%. So you can see, even having a t-stat of around 2.2 is still giving me a p-value that's less than 10%. I mean, it's 7.8 at this point. I think if you get around t-stats that are about maybe 1.9, somewhere in there, 2, maybe a little bit less than 2 for your t-stat, that's usually going to get you a p-value that's right around the 10% mark. So if you're only looking at t-stats, you can generally, again, use 2 or 1.9 as your kind of cutoff, and say, if I'm getting a t-stat that's bigger than 2, bigger than 1.9, then that usually means that that variable is going to be significant. If I'm getting a t-stat of 0.7 or 1.3, that's probably going to be insignificant. So, anyone else? I'm glad to see people moving again. It's always awkward when you're in the middle of and your Zoom profile video screen gets frozen in that strange position. It's really weird when it does that when you're in the middle of blinking, because you got that face. Anyone else? We still have 13 minutes of Zoom session. Okay. No one had any question about the state of North Utah? Did anyone see what the I know people are watching Georgia and Pennsylvania, North Carolina for the elections. Does anyone know what's been happening in North Utah? The state of North Utah, how their results have gone? We'll still have access to our notes and Excel sheets. Yeah, you can have access to almost anything during your EOM, just not outside websites, which will probably also include some of the, even though it's within Moodle, if you go to any of the supplemental videos down here, this little playlist, these are all YouTube playlists. These are all YouTube videos. So ProctorU will probably flag it and say, well, they accessed an outside website, even though you're in Moodle, you've got Moodle open here. If you're clicking on one of the videos in here, it's like you're opening sort of a mini YouTube browser within this Moodle page. So ProctorU is probably going to flag it. I always get a little email whenever you guys do things like that. These little flags say this person did this, or this person, their face was out of frame, like this, and they couldn't see it. For some reason, ProctorU doesn't like when you talk during your exams too. So if you're sitting here going, download the state crime Excel sheet, if you do that during your test, it's probably going to flag it and say this student was talking during their exam. I guess they think that there might be someone else in the room who's like miming to you or doing hand signals, and you're talking out loud to them. But it'll flag it for going to outside websites. So obviously you don't Google, how do I solve this problem? But you can certainly use, if you've got an Excel sheet open where you've been working on stuff, or if you've got the actual, the assignment itself, and you've gone in and you've typed your answers for these things, then yeah, you can leave those things open. You can have those things open. And ProctorU knows that, so it shouldn't ever give you any guff if you have an Excel sheet or a Word document open. We ever use a quadratic equation for prediction, the best fit line? We won't. Well, I don't know if we're going to use any quadratic equations. We don't have one. We don't have a quadratic regression in number 3 or in number 4, because all of these variables, these are all linear equations in the sense that they're just the variable itself. I do kind of mention, you can see an example of a quadratic equation here in question 2, because you've got total cost is a function of Q and Q squared. So if you were to graph this, if you were to go into Excel and make a column of Q's where you had different values of Q, and then you had a column of total cost where you use this equation to predict it, you'd end up seeing a total cost equation that had some kind of a U shape to it. So I don't actually ask, well, I guess I do ask you to type that in there. I don't ask you to run a regression in number 2. I could have, because we talked about regression this week. And we will do something like that in a couple of weeks from now. But you certainly can run a regression on data that is quadratic like this, where you have a Q term and a Q squared term. So we will do it, but we just won't do it this week. Can you use sign language? We'll probably have a problem. I don't know. I've never gotten a flag about students using sign language. You do have an actual real live person looking at you while you're taking this thing. So if you're there and you're just kind of like if you sit there, you kind of look off like you can't understand something, and then you kind of look like you're actually looking at someone, you're like, with your hands, you're like, oh, okay, oh, yeah, okay. Then they would probably flag something like that. If it seems obvious that you're trying to cheat by using sign language, then it will probably flag you. I think ProctorU's thing is they tend to be, is it gun shy? Is that the phrase I'm looking for? They're probably, they send me these little emails about, hey, this flag for possible academic breach of integrity. They're probably trigger happy. That's what I was looking for. They're probably very trigger happy with those kinds of things. Like if anything at all looks like it could be a possible violation, they're going to predict it and they're going to mention it to me. You know, you wouldn't want to be in a situation where a student was obviously cheating and the proctor, you were like, yeah, they're probably okay. They're probably not cheating. So as I said, they're probably a little trigger happy with saying that you're doing something wrong, even if you might not be. So most of the time, again, if it's something where people just are reading the question to themselves, or if they're there and they kind of, you know, they drop their pen or something and go out of frame for a second, it might flag it, but I look at that and I watch the video and like, yeah, they're just picking up their pen. So don't use that as a reason to think, aha, I'm gonna do whatever I can to cheat. Just don't cheat. Sorry, I have to actually recommend to people to not cheat in an MBA program, but you can easily obtain evidence of people cheating in my class. It's not hard to do. In an optimization like practice problem 2, which I thought I had open at some point. There we go. The answers work out well with the constrained budget. So there we go. Yeah, we have a budget there. Situation where the optimal choice makes us go over budget, but another choice exists without to be selected to exhaust the budget. Well, if you, I guess just by definition, if you have this budget and you know, by definition, you can't go over your budget. So you always try to do as best you can with the budget that you have. And so if you're not able to satisfy those conditions exactly, I don't think I have the answer key open for this yet. Let's see. And of course, with a lot of these practice problems, I set them up so that they can be solved nice and neatly, where the answer is going to be pretty obvious and pretty, as I said, pretty clean. So here, with this practice problem, and again, the video about this practice problem is available in the supplemental playlist. But you can see, you know, you're going through here and you look at your different budgets, and you can see some of these line up pretty closely. So we start out with two engineers and 3 researchers. So I can certainly see that those marginal products per dollar are not equal. And we end up saying, okay, what is the optimal mix? And I end up concluding that it is 3 engineers and 1 researcher. And look at that, they line up so nice. I mean, these are exactly the same. Marginal products per dollar are exactly the same. And you exactly spend all of your budget. So I'm like, oh, this is like perfect. I have the perfect solution to this because I get the optimization rule satisfied completely, where the marginal products per dollar are exactly the same at 4, and I'm spending every last dollar of my budget, so everything's fantastic. Even on the second round, where you have this 2.5, that's perfect. Everything lines up nicely. You know, in the real world, if things might not work out this nicely, you might end up having where, well, this one was 4.1 and this one was 3.9. That's the closest I can get. And the budget that we have isn't exactly 0. We still have $10,000 left over after that. You know, you try to get as close as you can to what you know to be the optimal rule. You certainly wouldn't want to sit there and go, you know, 5 and 3 spend our budget, so that's good enough. Because you'd say, well, no, I can certainly do better than the 5 and 3 situation here. I can kind of shift things around and at least get to this 4 and 4. So if you're not spending your budget exactly, again, you try to get as close to it as you can. I'm also realizing that people will probably freak out a little bit if I gave you a problem like that where they don't line up exactly. I try to always give you questions that will line up exactly. So if you get to a spot and you're like, I didn't spend all my budget here, or I didn't get numbers that were quite exactly the same, then you might have done something wrong, because I tried to set it up where it was a little easier to figure out. Once you can figure out the easy problems, then dealing with something that's a little bit harder should be okay for you. So if you can understand the concept of, you know, I want to try to get these marginal products per dollar to be the same, and I've done some examples where they were exactly the same, and they spent the entire budget. So at least I know on a chalkboard, this is how I would go about solving this. Well, when I get into the real world, which is usually a lot messier than what a chalkboard suggests, I still know the basic rule of thumb of what I want to do. I want to get, you know, these things to be, the marginal products per dollar to be close, and I want to spend as much of my budget as I can. So I don't know why this, you know, I'm always thinking in analogies. You might have in your head especially when you're in high school or in college. I have the perfect idea of who I want to marry. And this person's going to have these characteristics, and they're going to look like this, and their parents are going to be like this. And that's your ideal that you have. And you get onto the real, and so in your ideal, you have all these things about all these criteria that you want to satisfy. And in your mind, you're like, yeah, there's got to be someone out there who meets all that perfect criteria. When you get into the real world, it might not be exactly how you were planning, but you can still say, oh, this is a good situation. This is a good choice for me. Doesn't fit all my things to a T, but it does pretty good. So as I said, you have this rule of how you would make a decision here. And if it doesn't satisfy all those conditions exactly, you don't just throw up your hands and say, no, there's no way of figuring this out. We're ruined, we're doomed to making bad choices between engineers and researchers. You just try to get as close as you can. Satisfy as many of those conditions as closely as you can, knowing that you might not be able to satisfy them all perfectly. So again, if you're saying, well, the optimum would require us to go over budget. Maybe your company can give you a larger budget, but generally, just how these questions are usually asked, your budget is your budget and you can't go over it. So, you just try to, if you can't go beyond your budget to get to the optimum, you try to get as close to it as you can, staying within your budget. So, anything else? Last 2 minutes. I'm going to, if there's no other questions, I'm going to go online and look for network cables that can extend over however long it is from where our modem is to this room. It was sold on the concept that this modem was capable of 1 gigabyte speeds, and we're nowhere near that now, so we're probably too far away. Clemson or Norte Dame. Norte is that Spanish for north? Dame is female, so a female who lives in the north versus the son of Clem. I don't know any Clems. I don't know if they have, I assume some people named Clem have sons. So do I prefer the son of Clem, or do I prefer a woman from the north? I guess it would depend on what they were doing. If they were delivering me pizzas, I wouldn't really care. If they were reading me a nighttime story, I don't know if I would have much preference. So if this is a sports question, I'll just say I have no idea. I don't follow any of that stuff. So it's hard enough making breakfast for everybody. Yeah, college football, yeah. I have just enough economics knowledge to get by. I don't have enough knowledge in hardly anything else. So, and I don't have any desire to know anything about college football. So, especially in this time of pandemic and election crisis, how can you think about college football? So, it's mostly because I played soccer when I was in high school and college. And I don't know why, but the football team, they got to play in these big, huge stadiums. They got to have new jerseys every year, had their name on the back. And we always played, we didn't even play anywhere near our high school. It was at some other school. There was one of the middle schools. And it was like the field was just all weeds. There was no grass on our field. It was just all weeds. And you would get these hand-me-down jerseys from some player who wore it the year before with bad BO. And so it was always kind of like we were just sort of the forgotten team. So I always kind of resented the football team a little bit, which was odd because in college I actually worked for the football department, football office is my work study job. Because I didn't want to work in the cafeteria. So I volunteered to go work in the football office. And I still don't like football that much to this day. So that's my prejudice against football. All right, 1 minute over. Any other last minute questions? I will check emails over the weekend, and I know I have been bad about what we're supposed to be doing at the end of each week is to post feedback about the previous week's quizzes and whatnot. So I do need to go through and do what I do for that. It'll just kind of give you a sense of how many people have missed certain questions and what the overall scores were on each of the video quiz, self-assessment, EOM from last week. So I know I need to do that to the extent that that might help you. I know that also there's the very, very common complaint that people don't like not being able to see the questions they got wrong, and I can understand that too. So, but you know, we do what we can to prevent cheating in our program and to maintain its academic integrity. So, so I'll try to get those posted at some point, and I will check over your emails if you have other questions about anything. But most of your questions probably can be answered by looking over those practice problems and looking through the playlist here, the supplemental playlist, because this one has 16 videos in it, and it's about to have 17 once I upload the video from tonight. But lots of different Zoom seminar or Zoom tutorials from previous Zoom sessions on a lot of these different questions. So again, the question about negative t-stats, some stuff about calculus. So you can check those out too. But again, email me if you have other questions. So, all right, well, I will say goodnight to you all, and I will see you next week.